Referring back to the introduction of this last step, recall the second task for load application is to apply the lateral loads. We will now carry this out as part of the lateral analysis workflow in 3 simple steps. 1. Calculate the center of mass and masses in the building. 2. Create members at the translated center of mass at each story level. And 3. Generate and apply the lateral loads. 3 load actions will be defined. These are wind, gravity dead and gravity live loads, which are applied to represent notional horizontal or equivalent horizontal loading. Applied in 8 equal steps of 45-degree increments around the center of mass point at each story level. Each load type is given its own action as observed here, shown as W, W1 and W2. The tower design elements are also used to determine the load widths from kilonewton square meter values varying throughout the height of the building to be then applied as point loads at the center of mass locations. So, returning to our part model, here the model has pinned supports applied throughout for the lateral analysis workflow. Before we can apply the lateral loads, recalling the first step, we need to run the analysis of the gravity load cases. We choose to do this directly from the model. Observe the analysis tasks. The analysis will determine the story level masses, the story forces from the applied gravity loads, calculate combinations 3001 and 3002, and determine the center of mass at each level. On completion, we can open SSD and check the structure behavior. We can now progress straight to section 2 as we already calculated everything we needed. You can refer to the guidance provided in the text files that exist in the task structure, or to the workflow slides also produced to assist you through the tasks. Now we're ready to calculate the group task 2.1. The results tasks being calculated have been built to extract and export data from the CDB to Excel files for further processing. In this case, the center of mass and the story forces for each level relating to dead and imposed loading. Compiling results files is not covered in this course. You can refer to the SOFiSTiK help files for further information. Returning to the model, we will now open the Dynamo Player application and use a number of Dynamo scripts, the first of which will apply further elements to the model. These elements are generated and placed at the center of mass location, translated to each story level throughout the building. Most inputs open with defaults that don't require change. Check the file path for the source Excel file and click Browse to locate and select the correct Excel file. This will be the same path as your SOFiSTiK project file. Click Run to execute. Observe the newly generated analytical members in the view and their SOFiSTiK filtering ID naming. You can observe these more clearly within the predefined view template for center of mass. The next script we use will apply point loads to the newly created members at the center of mass in 8 directions. First, we address the variable live component as the script opens to predefined defaults that don't require any change. After review, click Run to execute. You can now see the generated point loads applied to all directions at each story level. Next, using the same script, we generate point loads for the dead load components. Please observe the values that require change and apply same changes. After review and making changes, click Run to execute. You can now see a further set of generated point loads. For generating the wind point loads, we use a further script. Here we have to select two Excel files. The first file contains the story level information. The second contains the basic wind load profile. Again, most input values don't require change. Please observe any input values that require change and apply same changes. After review and making changes, click Run to execute. You can now see a further set of generated point loads. This completes the lateral load generation exercise. To review the applied loads, we can utilize the SOFiSTiK Loads filter tool. We can also review the generated members, and you will observe that in addition to the generation of members at the center of mass, we also have members generated at the center of rigidity as observed by the naming in the SOFiSTiK filtering ID. In this project we don't need the latter, so we can delete these. In a large model, filtering of analytical members is enhanced with a further Dynamo script specifically developed for this task. The selection of elements works by selecting elements of matching string identification within the SOFiSTiK filtering ID. This is a very useful selection tool for a more granular selection of analytical members in your model. Here, we filter for the short form name of the center of rigidity, COR. Once we run the script, the elements are already selected where we can in this instance simply delete them. Continuing our review, we can observe that our generated members and their loads are within a stability core and don't interact with the structure. We need to address this. We'll do this by modeling analytical rigid links. In order to do this, we need to override our view template to show analytical nodes. We will be able to snap to these when creating the links. by applying temporary filtering to our 3D view and selecting the Analytical Links tool in the Structural Analytical Model ribbon under the Analyze tab, we can quickly model the links from the element under consideration back to the structure, in this case our semi-rigid diaphragm. Repeat at each level using the most appropriate method. Finally, to assist with future reference and selection, enter the short form name for the rigid links in the SOFiSTiK filtering ID parameter. Now we are ready to recalculate our model. This time, we only want to export the model and load cases as we will undertake the analysis in SSD. The analysis will calculate all basic load cases, now including lateral loads. In addition, the explicitly defined combinations and superpositioning load combinations will also be calculated. This is all undertaken with a single execution instruction under section 1.0 in SSD using the Calculate Group task. Once the model is exported, return to SSD, right-click the Group Task 1.0 system and select Calculate 1.0 system. After calculation, you can again observe the behavior of the structure under the new lateral load cases. Next, we can continue our workflow by jumping straight to section 2.2, where we will undertake a further linear analysis of the lateral load cases with applied stiffness modifiers. Refer to the README files and workflow slides to continue.